In this tutorial, we will be discussing the units of measurement. The unit system for science measurements is based on the metric system. It's called the International System of Units, or SI units. Notice this is actually a French term, Systems Internationale, which is why it's SI and not IS. So here are just a few of the SI units. Length is in meters, mass is in kilograms, notice it's kilograms, not grams. Time is in seconds, and temperature is in kelvins. Notice it's kelvins and not degrees Celsius. So it's based on the metric system. However, there are some deviations. The kilogram is the measure of mass, which is different than weight. The mass of an object is a measure of the quantity of matter within it, while the weight of an object is a measure of the gravitational pull on that matter. Therefore, the weight depends on gravity, while the mass does not. Here's a list of prefixes. Just like in the English language, where we have prefixes for words, these are prefixes for the units. These letters here go in front of the unit that we're referring to. For instance, if we're talking about computers and we're looking at bytes, we want to look at gigabytes. Notice 1 billion here. The multiplier multiplies the base unit by that quantity. So that means 1 gigabyte is equal to this many times bytes. So 1 billion bytes. Another example could be nano. Let's talk about grams. So that means 1 nanogram is equal to 0.000000001 grams. This number here is going with the base unit, while the number 1 is going with the prefix. You want to choose the prefix multiplier that is the most convenient for the particular measurement. You want to pick a unit similar in size or even smaller than the quantity that you're measuring. So let's take a look at a chemical bond. A chemical bond, let's say, is 1.2 times 10 to the negative 10. So when I look over here, I want something that's smaller than that value. So notice times 10 to the negative 12 is pico. So therefore, we measure it in picometers. So instead of having this long number to write out, I can just say 120 pm, 120 picometers. We'll discuss later in a different tutorial how to do those conversions. A derived unit is formed from other units. For instance, if we take volume, that's length times width times height. So these three sides are being multiplied together. As a result, that means meters are being multiplied together as well, not just the numbers themselves. So that comes out to be meter cubed. Meter cubed is now the derived unit. Another example is density, which is mass over volume. The amount of matter something has divided by the volume it takes up. So let's say mass is in grams and the volume is in milliliters. Well, this is now a derived unit because it's a combination of units. Many units of volume, a measure of space, are derived units, like you just saw. Any unit of length, when cubed, raised to the third power, becomes a unit of volume. For instance, cubic meters, cubic centimeters, so centimeters times centimeters times centimeters, and cubic milliliters. Milliliters times milliliters times milliliters are all units of volume. You may have heard things like liters and milliliters. Those are also derived units with the same general principle. They just have another set of numbers that go with them.